Good morning, students. Today I am going to start a new lesson which you have already studied all the basic concepts of that chapter in class 9 and class 10. Those concepts of the chapter probability I will be sending you through a broadcast WhatsApp group. So all of you just note down all the basic concepts related to this chapter in your fair notebook, and then after going through those points you can start solving the questions which I am going to teach you now. In class 11 probability I am deleting myself some of the questions. 16.1 exercise no need of solving, 16.2 no need of solving, omitted. 16.3 these questions 2, 3, 4, 5, 8, 9, 10, 12, 14, 15, 16, 17, 18, 19, 20 and 21. Only these questions will be solving in your fair notebook, and whatever the questions I will be asking in the exam, this will be from these questions only or related to this type of questions only. Now question number 2. In a coin, it is given that a coin is tossed twice. Two coins are not twice at once. Here the coin is tossed, single coin is tossed 2 times. So in a coin we are having only 2 outcomes possible, head and tail. So our sample points, head, tail, n of s will be 2. Event of getting a head in a throw of a coin. It is asked in the question that what is the probability of getting at least one tail. Whenever the question comes for at least condition, you must find it out its opposite. Event of getting a head. अपन at least वाला क्वेश्चन कभी भी बोलेगा तो हम उसका उल्टा निकालेंगे. उल्टा क्या होगा कि getting a head. टेल का उल्टा क्या हो जाएगा? Head. Event of getting a head in a single throw of a coin, only one edge, that is 1. So probability of getting a head in a throw of a coin, single throw of a coin, n of a upon n of s, by definition it will become 1 by 2. Since a coin is now thrown twice, it is given twice, a single coin is thrown. So probability of getting a head will multiply both the coins probability 2 times, 1 by 2 to 1 by 2, 1 by 4. Now this is the probability of getting a head. Now what will be the probability of getting at least one tail? At least one tail मतलब कम से कम एक या एक से ज़्यादा. So we know that probability of success plus failure is equals to 1. So by applying that concept, Q is equals to 1 minus P, 1 minus failure equal to success, that is 3 by 4. So probability of getting at least one tail is 3 by 4. This is the most important question. Question number 4. How many sample points will be there in a sample space in a deck of 52 cards? So there are possible outcomes will be 52. So number of sample points will be also 52. Event of getting a card is an ace of spade. There is only one card of ace of spade out of 52 cards, therefore n of a 51, and probability of a will be 1 upon 52. Event of getting an ace in a type of 52 cards, total number of ace cards is 4. So 4 by 52, 1 by 13. Event of getting a black card, so 52 cards में black cards 26, red cards 26. So event of getting a black card 46 by 52, that is 1 by 2. Now question number 5. A fair coin and a dice. A fair coin is tossed and a dice is rolled at a time. तो coin में हमारे पास 2 outcomes possible हैं. Dice में हमारे पास 6 है. So 2 into 6 sample points हो जाएंगे 12. That is coin. अब इसमें दिया हुआ है coin में हमारे पास एक तरफ लिखा हुआ है 1 और दूसरे फेस में लिखा हुआ है 6. So 1 and 6 only. We are taking 2 numbers. and in a dice there are 6 numbers 1, 2, 3, 4, 5, 6. What is the probability of getting a sum of 3 when we are tossing a coin and rolling a die at a time? So यहाँ पे आप देख सकते हैं सम 1 + 2 ही 3 बनेगा, 1 + 1 2 बन जाएगा, 1 + 3 4, 1 + 4 5, 1 + 5 6, 1 + 6 7, 6 के साथ भी करेंगे तो 3 नहीं बनेगा. So we are getting only one combination from here number 1 and here number 2. When we add up we get 3. So probability, so we are getting only one set only we are getting 1 and plus 2. So it will become probability of getting a sum 3 1/12. Next event of getting a sum 12. अब सम 12 के लिए यहाँ पे सिर्फ हमारा ऑर्डर पेयर बनेगा एक ही 6 and 6, 6 and 6. इन दोनों को एक नंबर यहाँ से लेंगे, 1 number I am going to take from here. So 6 + 6 will become 12. इसके अलावा कोई नंबर नहीं है जिसका सम 12 है. So that is event of getting a sum 12 will be probability of B will be also equals to 1/12. Now question number 3 and 8 will be homework for you. Question number 9, probability of A, that is given 2/11, and probability of not of A we have calculated. Since we know that probability of success plus probability of failure equals to 1, so by applying this concept we can get the value of probability of not of A equals to 1 minus 2/11. After LCM it will become 9/11. Now let's come to the next question, number 10. The given word is association. The number of alphabets in this word is 13. Event of getting a vowel and the number of vowels 1, 2, 3, 4, 5, 6 vowels are there. So probability of getting a vowel will be n of A upon n of S, that is 6/13. Now what will be the probability of getting a consonant? In a word the letters will be either a vowel or consonants. So some probability of consonant plus probability of vowel will be equals to 1. So probability of not of A we have to calculate. Since we know that the probability of not of A plus probability of A equals to 1. So probability of A, that is getting a vowel 6/13. You will subtract this value from 1, you will get the probability of getting a consonant, that is 7/13. Our next question is probability of A is 0.5, probability of B is 0.7, and probability of A intersection B is 0.6. It is a just oral question. Here probability of A intersection B clearly you can see is greater than any one of these probability. So P of A. So therefore it is not defined. If A intersection B is greater than any of the individual probability, then it will be not defined. Probability of A 0.5, 0.4, probability of B, and probability of A union B is 0.8. Here the probability of A union B is greater than probability of A and also the probability of B. When the probability of A union B is greater than our individual probabilities, then the probabilities will be defined. Next from question 14. If probability of A 3/5, probability of B 1/5, and probability of A or B we have to calculate it, and A and B are given mutually exclusive events. As in the chapter set, I have taught you about the mutually exclusive sets and or disjoint sets. Two sets are said to be mutually exclusive sets or disjoint sets if their intersection will be a null set. No any common element. If there is no any common element in any two sets, then those two sets are known as disjoint or mutually exclusive sets, and the number of elements in the intersection of their sets will be a null set. So here also its probability will be a null set whenever the two of the verbs A and B are the mutually exclusive events or disjoint sets. So by the theorem of the probability, this is one concept, this is one formula. Okay, तीनों में से कोई भी एक तीनों फॉर्मूला सेम है, लिखने का तरीका थोड़ा सा अलग अलग है. So as we have learned the applications of the sets, what problem? N of A union B equals to N of A plus N of B minus N of A intersection B. Here in place of N you have to write down P. P stands for probability. So probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. यूनियन की जगह प्लस भी लिख सकते हैं या और भी लिख सकते हैं, एंड इंटरसेक्शन की जगह डॉट ए डॉट बी लिख सकते हैं या ए एंड बी भी लिखा जा सकता है. एनी वन ऑफ द formula you have to write down while solving the problem. But here in the question it is given that A and B are the mutually exclusive events. So condition says that its intersection will be a null set. So this term is removed it because the events are mutually exclusive. So it becomes now the formula for this problem. Probability of A union B equals to probability of A plus probability of B, that is 3 by 5 plus 1 by 5 equals to 4 by 5. Next question number 15. Probability of E is given 1 by 4, probability of F is given 1 by 2, probability of E and F is given 1 by 8. We can apply probability of E or F it is asked. So E or F equals to probability of E plus probability of B minus probability of E and F. Substitute the values and get the answer. Probability of not of E and not of F means neither the E event is success nor the F event is success. We remember the De Morgan's law in we have studied set. So it is probability of E dash intersection F dash. So it will be equals to probability of E union F the whole complement. That is by De Morgan's law. So De Morgan's law A dash can be also written as universal set minus A, but here 1 minus probability of E union F. Probability of E union F complement will be equals to 1 minus probability of E union F, that is 1 minus 5 by 8 equals to 3 by 8. So this is one new formula for you. So write down this formula also, okay, in your concept. Now here comes the question number 16. The probability of not of E or not of F is given to us 0.25. We have to show that whether E and F, these events are mutually exclusive events or not. What is the condition for the mutually exclusive events? That is, their intersection must be a null set, that is equal to 0. So probability of E dash or means union not of F dash, again by De Morgan's law, E complement union F complement will be equals to E intersection F the whole complement, which is given by 1 minus probability of E intersection F. So 0.25 is the value of probability of not of E union not of F, 1 minus probability of E intersection F. By calculation we get probability of E intersection F equal to 0.75, which is not equals to 0. So therefore E and F are not mutually exclusive events. Question number 17. Probability of A, probability of B and probability of A and B is given to you. The values, you have to calculate probability of not of A, not of B and A of B. As we know that probability of not of A is equals to 1 minus probability of A. So 1 minus 0.42 will give you 0.53. Probability of not of B will given by 1 minus probability of B. So 1 minus 0.48 equals to 0.52. Probability of A or B by a formula, probability of A plus probability of B minus probability of A intersection B. After simplification, answer 0.74. Question number 18. It is given that the probability for the mathematics subject is 40%, so 40 by 100. Probability for the bio subject, so I have taken B, that is 30%, 30 by 100. Probability for both maths and bio, that is 10%. I have to calculate the probability for maths or bio. So again the same formula, probability of maths union B bio equals to probability of maths for probability of bio minus probability of both the subjects. Simplify it and we will get the result as 0.6. Now, question number 19. For the entrance examinations, it is given two of the examinations. So I have taken for the first examination E1 and for the second examination E2. Probability for E1 is 0.8, probability of second examination is 0.7, and at least one of the examination, either 1 or 2 or both, it is given 0.95. What will be the probability for clearing both the examinations, E1 intersection E2? We can apply the formula. Probability of E1 intersection E2 is given by probability of first examination plus probability of second examination plus probability of E1 union E2, either E1 or E2 or both. So we can simplify it and we get the final answer as 0.55. Here comes the question number 20. Probability of English and Hindi. The probability that student will pass the final examination in both English and Hindi 0.5, and probability of passing neither Hindi nor English E dash complement E dash intersection H dash 0.1, and probability of passing only in English 0.75. We have to calculate the probability of passing in Hindi. So first, by De Morgan's law, we know that probability of E complement intersection H complement will be equals to probability of E union H the whole complement, which will be equals to 1 minus probability of E union H. As this value is given to us 0.1 and 1 minus probability of E union H. So we get probability of passing either in Hindi or in English. 1 minus 0.1 we get it as 0.9. Now probability of E union H, as we know that the formula, probability of E plus probability of H minus probability of E intersection H. After substituting all these values, we get the probability of passing the examination in Hindi. It is 0.65. It is also an important question, and 21st also the most important one. Here it is given that the number of students who opted for NCC, I have taken the set A for NCC. So number of students 30, number of students who opted for NSS, that I have taken in set B. So N of B is 32, and the number of students who opted both NCC and NSS is intersection B, A intersection B 24. So first I have to calculate their probabilities. Probability of getting NCC 30 upon total is given to us, number of students is 60. Here it is given to us N of S is equals to 60. So probability of A 30 by 60, probability of B 32 by 60, probability of A intersection B 24 by 60. So probability of A union B I have to calculate in the first question. Either it is NSS or NCC, and neither NSS nor NCC, that is A complement intersection B complement by De Morgan's law, probability of A union B the whole complement, 1 minus probability of A union B. As I have calculated the probability of A union B in the first 19 by 30, so 1 minus 19 by 30 gives us 11 by 30. And the number of students who are opted for NSS but not for NCC. So NSS is our set B, opted NSS but not NCC. So it will be N of B minus A. Difference of set belongs to B but does not belongs to A. So what? Total number of students who are opted NSS subtracted from the total number of the students who have opted both NSS and NCC. Subtracted 32 minus 24. 32 minus 24 equals to 8. So probability of number of those students, those who are opting for NSS but not for NCC, it will be N of B minus A upon N of S, that is 8 by 60. 4 2s are 8, 4 15s are 60, 2 by 15 is your answer.